Hello there, welcome to Learner's Paradise channel. So this video is all about WPF core classes. So why I say this is a must watch in the title is it is very important to learn WPF, to know about these core classes. So it's easy to jump into other topics before learning this, but you end up with a lot of chaos and people talk about dependency properties and rendering, raster graphics, framework elements, etc., and then it's very easy to get confused going forward. It happened to me. I did the same mistake. So but yes, so this is, and these are the core classes. So when I prepared this slide and then I learned about these core classes, it made my life a lot easier going forward to learn about WPF. So before we get into each of these classes, let's go back and see how life was before WPF, that is prior to .NET 3.0 framework. Prior to WPF, that is before .NET 3.0 framework, where WPF was introduced in .NET 3.0. So we had to use the Windows API functions for developing Windows applications, and this was mostly to be called from C or C++ language. And these Windows API functions were broken up as mainly shell functions, where shell function is for representing the Windows GUI as a desktop taskbar and explorer. And then we had this CCL, common control library, which was used to give that Windows look and feel. And then for graphics we had the GDI, graphics device interface, for writing the graphics and then to generate the output to the output displays. And then the UI, user interface, which was for managing the input devices, the mouse and keyboard to your application. So and then all of them were implemented as mostly DLLs, where for shell we had shell32.dll, and for CCL I think we had comctl32.dll, not very sure, and then for GDI we had gdi32.dll and then ui32.dll. So the pros were the flexibility, because we had access to such low level functions. There was a lot of flexibility to write what we want, and then cons was that it is tedious. Of course, when you do a low level programming, it tends to get tedious. You have to break your head a lot about all the low level functions. So this is where in .NET 3.0 WPF was introduced, and its main standards, I just point out the main ones, is that it integrates all of the above Windows APIs, and then it provides them as a single platform. And then the next is it uses the vector graphics rather than the raster graphics that was used earlier. The benefit with the vector graphics is that you'll be able to scale your application on any screen, particular to a screen specific resolution, without losing any quality. So internally it uses 3D, direct 3D, and then it also uses a GPU if you have one, or else it does a software based rendering. And the third important point is that it represents, it helps us represent our UI as XML based. It's called as XAML in WPF or XAML. Now let's begin to understand each of these core classes in WPF, shall we? The very first class at the top is the object class. The object class is the parent of all classes in .NET framework. There's nothing much to say about the object class. And then there is dispatcher object, which of course derives from the object class as shown in the diagram. The dispatcher object class is one of the most important classes in WPF. Let's see an example why. Now in your application, say there is a main thread, and then it spawns another thread to create a combo box, spawns another thread to create a list box, spawns another thread to create a button. Sorry for the crappy diagram, by the way. Now if main thread wants to modify something in another thread, say it wants to change the name of the button, it cannot do it directly, because each element that is created within a thread is bound to that thread only. What I mean is, if anything has to be modified in button, it has to be by someone in that same thread. And then if something has to be modified in the list box, it has to be by someone in the same thread. So since main thread and button are in different threads, they cannot modify each other's data. This is where the dispatcher object comes into picture. The dispatcher object maintains a queue of work items in each of these threads, and then it is say in this case a main thread wants to modify the text of the button. It has to tell the dispatcher associated with the button thread to add a work item in the queue to modify the name of this button. So how it does is by calling one of these two methods called invoke or begin invoke. So using invoke or begin invoke, it can tell the dispatcher with a priority attached to add a work item onto any of these threads mentioned here. Then there is dependency object. The dependency object derives from dispatcher object. Before we get into dependency object, you should know what a property is in WPF. Well, a property is nothing but a variable in C or C++, except that it's a magical variable. So in WPF there are two types of properties. One is a regular property, and then there is a dependency property. So if your object derives from dependency object, then your properties have the capability to become dependency properties. So what a dependency property or a dependency variable can do is it can notify itself whenever its value changes. Great, isn't it? It can also validate its values. For example, if the value goes negative, it can set it to 0 or set it to 1 or set it to 2, however you want to write it. It can also set itself to default values when the object is created, and then many more things which an ordinary property cannot do, is not capable of. So an ordinary property can just set or get values in WPF, but then dependency property, like I said before, has many magical things that it can do or it's capable of. A freezable class derives from dependency class. If you want to derive an object that does not want to be modified, then simple derive it from the freezable class. So when you do that, it is said to be in a frozen state. That means nobody can modify this object, but you can still make a copy of these objects. But when unfrozen, it behaves like a normal object. So now WPF by default provides many elements like buttons, a list box, or brushes, etc. And some of them are have the ability to be frozen. So frozen objects, meaning those objects derived from the freezable class, are mostly used in the graphical system in WPF. I'll tell you why. As an example, say you have a window and you have a button within it, and you have painted the button with your favorite color. After painting a button in a window, if you make the brush object, brush is something that is used to paint the button. So since brush can be freezable, so when the window containing a button is resized, then your button need not be rendered each time, right? So your button need not display the pixels or re-render them, fire them again. So in this case, by making the button object as freezable, you're not asking the graphical system inside to repaint the entire button again and again. So if assume there are hundreds of such buttons on your screen, every time resizing a window will cause this pixels to be re-rendered again, and then it will put a lot of burden on the performance of your application. So in such cases, it makes sense to derive such kind of objects from the freezable class. A visual class derives from dependency class. Then visual class is used to display things on the screen. So what it does is it does the 2D rendering. Note, it's only for 2D. 2D rendering of all the controls on your screen. Controls in the sense buttons, list box, combo boxes. Everything will become visible on the screen only if they are derived from the visual class. And then applying any visual effects to these controls and find out what type of rendering to apply for an element. Basically, it's all about showing stuff on your screen. So if you want to write your own control, write your own button or anything else, make sure it is derived from visual class. Otherwise, whatever you write, nothing is going to show up on the screen. Now let's talk about UI element. and then framework element. UI element is a lie. No, it's not a lie actually. It's LIE stands for layout, input and event. So layout creates a layout using measure and arrange mechanism. So measure and arrange, we can look into it later. Input events in the window can be implemented as low level events. Say for example a mouse enter event. You want to change the color of a button on mouse enter. This mouse enter can be registered as a low level event. So there is delivery guaranteed. That means your operating system, underlying operating system will tell you when the hardware mouse enters over your button, and then the event is fired to you. And then the last one is the event. It supports routed events, which again we'll look into going forward. So this is about the UI element, and then framework element derives from UI element, and framework element is SAD. It's not SAD actually. Again, SAD stands for styling elements, animation support and data binding. Now framework element is a very important core class because it adds most beneficial features here. So about the styling of the elements and then animation. There was basic animation support before framework element, but with animation given in framework element, you can have your own storyboards, etc., which again we'll get into going forward. And then data binding is one of the most critical features of WPF. So other than this, the layout which was already there in UI element, there is an addition added on this layout as to how it is aligned and what is the gap between each elements. Basically it's all about the alignment, horizontal alignment, vertical alignment, and what is the minimum width between each of these alignments is all addressed in framework element. Now let's talk about the control class. The control class derives from the framework element. A control class offers you templates to change their basic behavior. So you can create your own UI element without having to inherit from control class. Surprised, isn't it? So even though we think button, list box, text box or any other UI elements derived from control class, actually they don't get their visual properties from control class. They get their visual properties either from framework element or UI element, and they are displayed on screen using visual class. But since button derives from control class, you have the flexibility to change the basic behavior of how a button looks. Say it has sharp edges, sharp corners, and you want to make them rounded, or you want to apply a color which has a gradient look on the button. You can do that on the button element because it is derived from control class. Visual 3D and UI element 3D are simple classes. They are for 3D content, whereas visual and UI element that we discussed earlier were for 2D content. So going forward, content element. So content element class is for text content, whereas the UI element class was for UI elements. Now why is it like this? Why does content element directly derive from dependency object, as you see in the diagram, and then UI element derives from visual, and which in turn derives from dependency object? Historically, text has layout needs that are not the same as UI elements, like a button or a text box or any other element. So hence the content element derives directly from the dependency object. So now you might ask, so then how does it show up on the screen, because there is no visual class to render? Well, the answer is it has to be a child of some element which is derived from visual class. So framework content element class is again for text content. It runs in parallel with the framework element that we discussed earlier. It's almost the same, except that some visual properties which are defined in framework element are absent here. So as we know, visual properties are not required here in framework content element. As of this recording, I was unable to find a single comprehensive tutorial that explains the core classes of WPF, which is very critical to know. So I hope this tutorial was helpful to you. So if it was, kindly subscribe to our channel. There are more such videos coming up.